guys, for the inconvenience. Okay, so where were we? We were on the advantages of, like, what does three-tier architecture provide, right? It's scalable, right? Now, talking about the advantages, first of all, now the two-tier architecture system is easier to maintain. Why it is easy to maintain? Because we have only two instances, that user layer and the database layer. User will interact with the database and will get for its query from the database. Now, this system is a bit difficult to implement. Now, first we need to write the authentication layer logic itself. We have to layer which handle all the authorization, authentication, the mechanisms which we discussed recently, right? Now, theta architecture system security, right? How it ensures the security, as I told you, authentication and identifying the request, right? It is all taken care by the application layer, right? Now we have different architecture, that is 4-tier, 5-tier, but they are the extension of 3-tier system. Now, talking about the scalability, you should be wondering that how I can increase the load from here. I can that hey, increase the right, is that right? But to logic here again, and not the application here, but the working, right? You one will be interested, then you one the V2. So this is kind of a manual process, right? You have to write logic layer of this system into this system again, and then your user base increases. Then you have to write the same logic, right? Happens in three system is, since you have logic layer, right? Let's say this is ALA. We already discovered its functionalities. Your user base. Let's say I'm now getting U1 from U100. U100. Now, the query, let's say, query here. I have logic. I have some logic to the database. To the now apply a function. Let's say from U100, I will apply, say, just writing a simple function for you, that if I is greater than equal to 1 and id is less than equal to, right, go to d1, right, else database, right? So this is how your scalable systems are created. Go to if you want to study, you can study about some of the system, that is the load balancers. Right? This thing, load balancers. How do load balancers distribute? You have another use distribute the load U101 in 10 distributed databases, right? So these you can learn about load balancers, then you will get a good idea that hey, in microservice or monolithic architecture system, how do we distribute the load, right? Am I clear up to this, guys?
Yes, sir.
Okay. Okay, talking about the data independence, right? Talking about the data independence. Now, what is data independence? We have two kinds of data independence. Basically, your user view should not be affected with any kind of change in the storage or in the how do we store the data, right? We have physical data independence, we have logical data independence, right? Now, what is physical data independence? That is, no matter what you change in this physical aspect of your DBMS, right, or your database, that is, if you change the storage device from HDD to SSD, that is solid state drive, or you change the file organization method, that is, if you want to store the your data in form of a heap or in form of a B tree or a request tree. You want to remove or add indexes. You want to apply some compression techniques, right? Your user view should not be affected, right? Your user view should not be affected. Let's say your user view was showing the data in form of rows and columns only, right? Rows and columns only. Now you have this table, but let's say this table is being fetched from a database, right? Database which is having a heap, or let's say a B tree IMPL, right? Now even if I change the mechanism, my this is my user view, okay? This is my user view. So my user view should be independent whatsoever I make the change in the storage mechanism. I should be able to view the same data as it is. Now talking about the adding or removing indexes, right? Let's say my table is too large, right? I am having, let's say, 1 million rows. Will my view change? No, my view will not be changed. Why? Because in what does indexing do? Indexing is used to retrieve the data faster. It doesn't change your view. It just increase the retrieval speed of the data, right? So your view is not changing even if you add an index to the table, or if you don't add the index, the data will be fetched in the same way and it will be presented in the same way to the user, right? So your user view does not change with any change in the physical aspect of your database system, right? Now logical data independence. Am I clear with the physical data independence? Okay. Now the logical data independence. Now the logical data independence means that I can change the relationships. I can change the relationships my user view will not be affected, right? Everything revolves around the user view, right? Not the data representation will not be affected even if your entity information change. Let's say I am having a student. Where did I go? Okay. Let's say I am having a student. Now a student. Let's say a course, right? Course table, right? Even if I say, hey, I have information that hey, one student can get admission, right? I say each course will be opted by one student, right? So this is free. We are having a one relationship. This is the because data, let's say, and this history, every student will have a subject. Let's say Sanjay, and this is every will be having unique subject, right? But the view is not changing. Similarly, even if another, and now it is not one, it is not one to one, it is one to n, right? One to one. That is, can have multiple. Now, since my view is not changing, the mechanism of showing the external view is same, just the data is changing, right? So this is known as logical data independence. That is, if even if you change the relationship between tables, right? You change, that is, you merge some entities or you split some entities, your view should not be changing, right? So this is known as, so we have this layer, right? We have a view level which is kind of the user acceptance, right? Then we have the physical data independence. The physical data independence sits between the set of relations and the physical storage. Similarly, the logical independence sits between the set of views and the set of relations. Okay, am I clear up to this, guys? Okay, let me know if I'm going too fast. Okay, now talking about the database designing. Can you please type in the chat what do we consider when we, let's say, hey, please create a database of e-commerce platform? Please give your answers. Like, I'm open to discuss. Let's say I'm giving you a question of, hey, please design a e-commerce platform. What will you ask? What questions will you ask? I just want to know though, your thinking. Let's start with this topic. You can type in the chat, don't worry. Like, I'm not judging, but yeah, this is the way of learning. Guys, please type in the chat. Right type of products. Okay. What else do you need for an e-commerce platform? Cost of products, price, quantity. Okay. Requirements, customer base. Nice, Nandakishore. Seller. Okay. Flow chart of the database scheme. Okay. Flow chart is kind of a step when you create a database. Okay. It is not basically a requirement. Bhaskar and V. Okay. Feedback, listing the products in proper form, right? So listing the products in proper form is basically a kind of logical implementation, right? How do you want to list your products? It's not associated with by designing a database, right? It is associated with how you want to view the product, right? Let's say I'm doing sorting. It's not associated with how am I storing the product. It is associated with the view level, right? User and authentication, right, Amrita? Categories and subcategories, target audience, right? Anybody else wants to give it a try? Segregation of products already done. That which products which we need to cater. User admin database system. Yeah, right. So let's think, right? Let's think how do we design a e-commerce platform. Let me just share my screen. Okay. Now let's say this is a client, right? Client is asking you, let's say for here example, this is Nanda Kishore, right? Okay, I'm taking your name, but don't feel offended. Okay, good. So this is Nanda Kishore. Okay. Now client is saying, hey, can you please design a e-commerce platform for me, right? Can you please design a e-commerce platform for me? Nanda Kishore, being new to this, he will ask the relevant questions, right? He's not new, sorry, he is experienced to this, that hey, I know you want to design the e-commerce website. I need to know what are your requirements, right? Now the client will list its requirements, right? Client will list its requirements. Let's say my first requirement is my first requirement is I want to make it available for my city only. City only. I'm just listing down the requirement. The priority of the requirement may change. Okay. Now, what does it signify? What does it signify? Available for my city only. That is, if you are residing in Tamil Nadu, the client is saying, I want this site, this website to run only in Tamil Nadu or only for Tamil Nadu users. Now, this is a question of the user base, right? The user base. That hey, what is your user base? Let's say now you are asking. Now Nandakishore will ask. Now Nandakishore will ask the client, should I take about 1 million people? Let's say 1 million users, right? 1 million people or 1 million users. So this will be our user base, right? Now, what kind of e-commerce platform are you triggering, right? Or are you expecting? Now there are various kinds of e-commerce platform, or let's say shopping cart, right? If you talk about Misho, right? If you talk about Amazon, now Amazon, Flipkart are giants in e-commerce platform. They sell everything. They sell everything from 0 to 100, right? A to Z. So you want to say that what kind of products do you want to sell, right? The kind of products.